Imagine you and I are standing in front of the same red apple. I point to it and ask what color it is. You say red, I say red. Then I show you a strawberry, red, a stop sign, red, a green leaf, green, a blue sky, blue. We agree perfectly. So obviously, you and I see the same colors. Right? Not necessarily, because there is a surprisingly large gap between agreeing about a color and knowing what another person's experience of that color actually feels like. Start with what science can measure. Light reflected from the apple enters your eyes. In a person with typical color vision, 3 classes of cone photoreceptors respond differently across the visible spectrum. These are usually called S, M, and L cones, referring roughly to sensitivity towards shorter, medium, and longer wavelengths. Your visual system compares and transforms information originating from those receptors. Eventually, you experience color. My visual system does something broadly similar, and that similarity is incredibly useful. We can perform color matching experiments. We can test which colors people can distinguish. We can measure sensitivity to different wavelengths. We can study photoreceptors. We can record neural activity. And we know that human color vision is not perfectly identical from person to person. Even among people classified as having normal color vision, there are measurable individual differences. The pigments in our eyes can vary. The lens and other structures that filter incoming light can vary. The relative populations of different cone types can vary substantially. Age changes the optics of the eye too. So the biological equipment producing your visual experience is not necessarily an exact copy of mine. Yet something fascinating happens. Despite all that biological variation, our color perception can remain surprisingly well aligned. Our visual systems appear able to compensate for some differences, and our shared environment gives us common reference points. The sky, plants, skin, food, objects. From childhood, we also learn the same color categories. Someone points to a strawberry and says red. You learn red. Someone points toward grass and says green. You learn green. Eventually, the word becomes so automatic that it feels attached directly to the experience. But words create an interesting problem. Suppose I could somehow borrow your eyes and brain for 10 seconds. I look at the apple, and suddenly I discover that what you have always called red feels completely different from what I have always called red. Maybe your experience of red resembles what my experience of green feels like. But you have called that experience red your entire life. When you were a child, people pointed to stop signs and said red. So you learned to call your experience red. When I was a child, the same thing happened to me. We would therefore use exactly the same word. We would stop at the same traffic lights. We could organize colored objects correctly. We might even pass standard color tests. Yet internally, perhaps our experiences would be different. This is related to a famous philosophical idea called the inverted spectrum. The simplified thought experiment asks whether 2 people could behave identically while having systematically different private color experiences. It is important to be careful here. Science has demonstrated real differences between human visual systems and measurable differences in aspects of color perception. But that does not demonstrate that 2 otherwise typical people secretly experience completely inverted color worlds. The inverted spectrum is primarily a philosophical thought experiment, and it exposes a limitation in how we compare conscious experiences. I can measure the light entering your eye. I can examine aspects of your retina. Researchers can study activity in your visual system. I can ask you to compare colors. You can describe what you see. But eventually, every measurement reaches the same boundary. I receive information about your experience. I do not literally receive your experience. There is no obvious instrument that lets me experience your red from the inside. Philosophers often discuss these subjective qualities of experience using the term qualia: the redness of red, the painfulness of pain, the particular character of smelling coffee, the sensation of hearing a violin. Science can investigate the physical stimuli, sensory systems, neural processing, behavior, and reports associated with these experiences. But explaining how those measurable processes relate to subjective conscious experience remains a major problem. And color gives us an unusually simple way to notice it. Because consider everything we can agree on. We can agree that two patches match. We can agree that one color is brighter. We can agree that red differs from green. We can measure the wavelengths involved. We can predict many color matches from the responses of the cone systems. We can identify forms of color vision deficiency. We can even build screens that exploit human color vision by using only a few primary colors to generate an enormous range of apparent colors. Science understands a remarkable amount about color vision. And still, one tiny question remains strangely difficult. Does your red feel like my red? Maybe it does. Given broadly similar human biology and shared patterns of perception, there are good reasons not to assume that everyone's experience is radically different. But similarity is not the same thing as direct access. I cannot simply step into your consciousness and compare, and neither can you step into mine, which means the original question has an unusual answer. Do you see the same red I see? Scientifically, we can compare our visual systems and our behavior with extraordinary precision. We can discover ways they are similar and ways they differ. But if by same red we mean whether the private subjective character of your experience is exactly identical to mine, we currently have no simple direct test that settles that question. And perhaps that is the most interesting thing about the red apple. Nothing about it has changed across these 3 episodes. It has been sitting there the entire time. But first, red seemed like a property of the apple. Then it became an interaction between light, an object, an eye, and a nervous system. And now even when 2 brains successfully agree that the apple is red, we discover that agreement does not automatically give either person access to what the other one experiences. We share a world remarkably well. We agree on its colors. We give those colors names. We build paintings, photographs, screens, traffic signals, and entire visual cultures around them. Yet behind every pair of eyes is a perspective on that world that no other person can simply open and inspect. Maybe your red is exactly like mine. Maybe it is not quite identical. For now, the remarkable part is that despite never being able to directly compare them from the inside, we have still managed to agree on what to call the color of the apple.